Welcome to Why, where questions are more powerful than answers. So Veritasium just dropped a video on one of the oldest mathematic puzzles in history. It's called the Goldbach Conjecture. It's elegant, intuitive, yet it's still unsolved. But after watching his video, I could not shake this idea out of my head. A quick refresher, the Strong Goldbach Conjecture says that every even number greater than or equal to 4 is the sum of two primes. For example, 10 is equal to 5 plus 5 or 28 is equal to 11 plus 17. On the other hand, the weak Goldbach conjecture that was proven in 2013 says that every odd number greater than or equal to 7 is the sum of 3 primes. For example, 7 is equal to 2 plus 2 plus 3 and 15 is equal to 3 plus 5 plus 7. The weak one has been proven, but the strong one is still open for research. What if the strong version of Goldbach is already hiding inside the weak one? This might not just be a coincidence, it could be a structural shortcut that we have overlooked. Now here comes the twist. Take any odd number. O is equal to prime 1 plus prime 2 plus prime 3. This is guaranteed by the weak conjecture. Now, we subtract one of the primes from this equation. O minus P3 is equal to P1 plus P2 is equal to E, which means that this results in an even number. That's a valid, strong Goldbach pair. So for every odd number, we generate a new even number. Since there are infinitely many odd numbers, so we get infinitely many even numbers that satisfy the strong Goldbach conjecture. Of course, that does not prove the strong Goldbach, because maybe not every even number gets hit this way, but it shows that the structure of the weak version contains a lot of strong cases. Here's where this gets interesting. We've already checked that the strong Goldbach conjecture for all even numbers up to 4 quintillion. That means for every one of those we know that even is equal to prime 1 plus prime 2. Now we just add 3 to each one of those. That is a weak Goldbach triple, but that's valid. So for billions and billions of odd numbers, we know that the weak triple includes a 3. And if this is the key, then 3 always works in weak decompositions. Then strong Goldbach follows immediately. So here's the big idea. Maybe we've been trying to prove strong Goldbach directly, where we should be asking, is every even number the difference between an odd number and a prime in a weak triple? That's a structural question, not a numerical one, and it opens up a whole new way for thinking about the problem. Now, I'm not a mathematician, but I just noticed something while watching his video that felt oddly beautiful and intriguing, so I thought I would make this video. Now, if you're working on this problem, or have something insightful that you would like to share, my email is in the description and you can contact me. And a huge thanks to Veritasium for inspiring this rabbit hole. Maybe we can explore and dig deeper together. So this was my first video on why. Thanks for watching and for thinking. If this made you curious, consider subscribing to this channel and hitting like. More ideas like this one are on the way.